Is it visible? Is it visible?
Yes, sir. Yes, sir.
Okay. Without wasting time, we'll start the class now. So last class we have discussed about inverse Laplace transforms. That is how inverse Laplace transform is defined. And see, this is the inverse Laplace transform definition. Okay, that is if L of f of t is f bar s, just taking this Laplace operator this side, it becomes L of f of L of L inverse of f bar s is equal to f of t. So we have solved some examples also, basic examples. For that purpose, you need to remember all this. L inverse of k by s is k. L inverse of 1 divided by s minus a is e to the power 80. 1 divided by s plus a is e to the power minus 80. L inverse of 1 divided by s square plus a square is 1 by a into sine 80. L inverse of s divided by s square plus a square is cos 80. L inverse of 1 divided by s square minus a square is 1 by a into sine hyperbolic 80. S divided by s square minus a square is a cos hyperbolic 80. And you should concentrate more on this, because with respect to this L inverse of 1 divided by s raised to n plus 1, you are having two results depending on the nature of n. If n is a rational negative number, then in the denominator you are going to use a gamma function. Otherwise, if it is a positive integer, you are going to use a n factorial. Okay, hope all of you remember these results. With respect to this, we have taken some examples also. Today we will continue with some more examples. Okay. Okay, I think yesterday we have solved three examples, right? Am I audible clearly?
Yes, sir.
Okay, now we'll take one more example today. That is, find the Laplace transform of 2s minus 5 divided by 8s square minus 50 plus 4s divided by 9 minus s square. Okay, now see, this can be written as a L inverse of, first we will write this, L inverse of 2s minus 5 divided by 8s square minus 50 plus 4s divided by 9 minus s square. Now, as I told you, you observe here, in the numerator quantity you are having s, in the denominator you are having a s square. S minus something you are having, in the denominator you are having s square. So, we should be very, very careful here. So, what we will do first, in the denominator, what I told you, whether it is s or s square, its coefficient should be 1. So, first we will make, without worrying about the numerator, first we will make that manipulation here. What is that? L inverse of operating this separately to this, separately to this. I'll tell what to do. Then next, what we need to do, simply just we'll take this 8 in the denominator common outside here. If you take 8 common outside, numerator 2s minus 5 as it is, divided by, that becomes s 8 into s square minus 50 divided by 8. So that if you take this 8 inside again, original thing remains as it is. Now immediately after that, see, I have written here it is plus, but I have written minus here. Why? Because see here, standard result is it should be of the form, denominator should be either s square plus a square or s square minus a square denominator. But here your constant s square is with the negative sign, so we want to make this a positive. So I have taken minus sign outside here. If we take minus sign outside here, what happens? This becomes, if see, if you take minus sign outside, this becomes minus s square minus 9 it becomes. So plus divided by this minus becomes minus, so I have written minus here, minus this 4 also I have taken outside. L inverse of making the manipulation, I have written this one as s divided by s square minus 9. Okay, s square minus 9. Okay, now what we will do immediately after that, just one more simplification we will do here. This 1 by 8 is constant, I will take that outside. Then here we can write it as here, we can write it as 2 4 za, okay, 225 za, 2 4 za, 225 za. We can simplify this, that becomes 25 divided by 4. 25 divided by 4 can be written as 5, see, 5 by 2 whole square. So entirely this thing can be written as 2s minus 5 whole divided by s square minus 5 by 2 times 5 divided by 2 raised to 2. Okay, minus this as it is 4 times L inverse of s divided by s square minus 9. Now this is only one term is there, nothing to worry about this in the numerator. Okay, then here in the numerator you are having two terms, so splitting of this term is not possible here by partial fraction method. So what we can do here is just simply what we will do, taking numerator and denominator separately, sorry, taking a denominator separately to the these two numerator terms. So you can write this one as say operating this L inverse and taking a denominator separately to these two terms. What happens? So 1 by 8 as it is, I have taken these two outside. Let us take these two outside. L inverse of it becomes s divided by s square minus 5 by 2 times 5 divided by 2 whole square. Okay, this is okay. Then this is minus as it is, then multiply this 5 I have taken outside. Okay, 1 by 8 also we have multiplied here, so it becomes 1 by 8 into 5 to L inverse of what you left with once you take the 5 outside, 1 divided by 1 divided by square minus 5 by 2 times 5 divided by 2 whole square. This is one term. Next, minus 4 as it is, L inverse of this term as it is here. Okay, next here further you can simplify this one as a 2 ones are 2 fours are nothing, no issues with that. Now L inverse of, you concentrate on this term, this is of the form s divided by s square minus this is a square. A is equal to what you are having here, 5 by 2. So L inverse of s divided by s square minus a square is what, cos hyperbolic 80. So that becomes what here, cos hyperbolic, in place of a you have 5 by 2, therefore it becomes cos hyperbolic 5 by 2 times t. Now this 1 by 2 1 by 8 as it is, 5 as it is. Now you concentrate on this, this is of the form L inverse of 1 divided by s square minus 5 by 2. So that is standard result is L inverse of you are having if it is 1 divided by s square minus a square, a square, sorry, s square minus a square, you can write this one as 1 divided by a into sine hyperbolic a into t. Okay, therefore here a is your a is a 5 by 2 here. If you take that 5 by 2 it becomes in here, if you substitute here that becomes 1 divided by 5 by 2 into sine hyperbolic 5 by 2 times t. But if you take this 5 by 2 to the numerator, that becomes what, 2 by 5, which I have written directly here, that is 1 by 8 as it is, 5 as it is, 2 by 5 times sine hyperbolic 5 by 2 times t. Okay, then minus, now this is of the form yes again s divided by s square minus a square. So this 9 can be written as 3 square, so a is equal to 3 here. So you can write using standard result this one as 4 times cos hyperbolic 3t. So again in the next stage what happens, this 5 get cancels, 2 ones are 2 ones are, so this becomes 2 fours are. So finally what you will get, 1 by 4 times cos hyperbolic 5 by 2 times t minus 1 by 4 times this is, see this get cancelled, 2 ones are 2 fours are, 1 by 4 is remaining, sine hyperbolic 5 by 2 times t minus cos hyperbolic 3t. If you write this much your answer is over. But sometimes what happens here 1 by 4 is common, 1 by 4 is common, you can take that outside. In some books they have given answer as this one. So now we will check how you will get this as your answer. Okay, now if you take 1 by 4 common, if you take 1 by 4 common from the first two terms, you left with what, cos hyperbolic 5 by 2 times t. Cos hyperbolic 5 by 2 times t means by the basic definition it is e raised to 5 by 2 times t, e raised to 5 by 2 times t, then minus, sorry, plus e to the power minus 5 by 2 times minus 5 by 2 times t whole divided by 2. Then this is minus sine hyperbolic 5 by 2. We can write this one as a 1 by 4 we are already taken outside here. This is e to the power 5 by 2 times t. Okay, then this is minus e to the power minus 5 by 2 times minus 5 by 2 times t divided by 2 you will get divided by 2. Now see what happens. 2 is the LCM. If you take the 2 outside here, I will get indeed we will get 1 by 8. So 2 is the LCM anyway. So definitely what happens here, e to the power, this becomes 5 by 2 times t as it is, plus e to the power minus 5 by 2 times t as it is, minus 5 by 2 times t as it is. Now this is minus here, so take this minus sign inside. What happens here? That becomes minus e to the power 5 by 2 times 5 by 2 times t, and this is minus into minus plus e to the power minus 5 by 2 times t, 5 by 2 times t minus. Okay, so this is t here. Okay, this is plus e to the power 5 by 2 times t, and this is minus e to the power 5 by 2 times t. These two terms will get cancelled. So now these are two terms with the two terms, two same terms with the same sign. So what happens? It becomes 1 by 8 into 1 by 8 into bracket 2 times e to the power minus this is 5 by 2 times 5 by 2 times t. So what happens? 2 ones are 2 fours are. So you will get you can write this answer as a for these two terms. Reduced simplified answer is 1 by 4 times e to the power minus 5 by 2 times t minus cos hyperbolic 3t. Is that clear? Is that clear?
Yes, sir.
All of you, is that clear? Clear, no? This simplification.
Yes, sir. Yes, sir.
Okay. Now, please, if you are not understanding anything, if you have any difficulty, please ask the questions in between. Okay, no issues with that. Okay, no problem if you ask the questions, or some difficulties if you are having, you can make it clear here only. Okay, next we'll take a see we'll take another two different type of examples which are very very important. See, these two examples, these are also asked in your examination. These are also asked in your examination many times. So we'll take those two examples. It is, find the inverse Laplace transform of number one, s plus 2 whole cube divided by s raised to 6, and this one by one we'll consider. First we'll consider first example, that is solution number one. It can be written as a L inverse of s plus 2 whole cube divided by s raised to 6. Okay, now see here, it is s plus 2. If it is only s plus 2 without this s whole cube, you would have taken this denominator separately to the numerator, then you would have simplified it very easily. Now what we will do, we'll expand this using the formula a cube plus a plus b whole cube formula. What is a plus b whole cube? A cube. See here, this is your a here, this is your b. So a cube plus b cube plus 3 times a square b. See, I will write here that formula. So if you take this as e, this is a cube, this becomes a cube plus b cube, plus you can write this one as 3 times yes, what is that, a square b plus 3 times a b square, a into b square. Am I right? Am I right or wrong? So let me check here what happens. A cube, that is s cube, b cube. B cube is 2 cube, that becomes 8. Okay, then 3 times a square b. 3 times b is what here? 2. So 3 into 2 is 6. A square is s square, so it becomes 6s square into 3 times a into b square. B square is 4 here, so b square becomes 4. 4 3s are 12. 12 s it becomes. Is that clear? So divided by, it becomes s raised to 6. Now what we will do, we will take this denominator separately to the these numerators. We will split up this sorry denominator separated to the this numerator. So what happens, it becomes see here, s cube divided by s raised to 6 first you will get. So s cube get cancels here, s cube s cube get cancels. So what happens, yes, s cube from this three terms get cancelled, so you get 1 divided by s cube. plus 8 divided by, you will get s raised to 6. Then here 6 as it is, this s square, then s square get cancelled, so you get 6 divided by s raised to 4. 12, 12, then this s and 1 s from this get cancelled, so you get 12 divided by s raised to 5. Okay, now since this inverse operator is a linear operator, we will operate it term by term, term by term, sorry, term by term to these terms. See, all these are in the form 1 divided by 1 divided by s raised to n plus 1 type, that is L inverse of 1 divided by s raised to n plus 1. Now observe all the terms here, observe powers of s here, all are positive integers. So which result you are going to use? You are going to use t raised to n divided by n factorial, n factorial. So now coming to the first term, this term, so n plus 1 is equal to 3 you are having here. If n plus 1 is equal to 3 means what you are going to do? N value will be 1 less than this. That is what? If it is 3 here, you will get n value as a 2. So for the first term, inverse transform of first term is what? T square divided by 2 factorial. Now this 8 as it is here, here your n plus 1 is a 6. If your n plus 1 is 6 means what happens to your n value becomes 5. So using this result, wherever n is there, put 5, you will get 8 as it is, t raised to 5 divided by 5 factorial plus 6 as it is. So when you come to this becomes L inverse of 1 divided by s raised to 4. So n plus 1 is 4 means n is equal to 3. You will get 6 times t cube divided by 3 factorial plus, here when you come to this term, 12 as it is, n is equal to, n plus 1 is equal to, you will get 5 here. So n is equal to, you will get 4. So it becomes t raised to 4 divided by 4 factorial using this standard results. Now simplifying and rearranging terms, if you want you can write it in the descending order or ascending order, but I have written answer in the ascending order here. Ascending order means starting from the lowest power to highest power. So here this t square as it is, 2 factorial is 2 only, then I have written here. Okay, next I will consider t cube term. T cube means t cube as it is, so it becomes divided by 3 factorial means 3 factorial value is 6. So this and this get cancelled, so you get t cube only plus t raised to 4, t raised to 4, how it becomes yes, t raised to 4 divided by 2 I have written. Why it is t raised to 4 divided by 2? It is yes, 4 into 3 into 2 into 1, 4 factorial. Okay, so 4 3s are 12. So what happens? It is indeed 4 factorial is 24. So 12 ones are 12 twos are, but I want, so this becomes 4 3s are 12, 12 12 get cancelled. You get t raised to 4 divided by 2. The next here I have written this one as t raised to 5 divided by 15. How it becomes? Yes, can anybody tell me? T raised to 5 as it is. So this is 8 divided by 5 factorial means you can write this one as yes, 5 into yes, 3 into 4 to the 8 into 1 you will get. So this 8 get cancels. 5 3 is 15. So you will get t raised to 5 divided by 15. Hope this example is clear. Is this clear?
Yes, sir.
Clear, or you have any difficulty, any confusion in understanding? Clear, no?
Yes, sir.
Okay. Next we'll take a next example. What is your next example? What is your next example? That is, your next example is yes, your next example is find the inverse transform of 1 divided by s into underscore root s plus 3 divided by s square into underscore root s minus 8 divided by underscore root s. Let us see what. So consider L inverse of 1 divided by s into underscore root s, 3 divided by s square into underscore root s minus 8 divided by, it is 3 divided by, okay, by mistake I said t there, 3 divided, okay, minus 8 divided by underscore root s. So Laplace operator is a linear operator, so I will operate this term by term. Laplace inverse operator is linear operator, I will operate it term by term. So it becomes L inverse of this see, square root of s is the square root of s can be written as s raised to 1 by 2. S raised to 1 by 2 into s. S raised to 1 by 2 into s, that can be written as s raised to 1 by 2 plus 1. So that becomes s raised to 3 by 2. We have written it. Then this 3 is constant term. I'll take that outside here. Then L inverse of this is s square into s raised to 1 by 2. S square into s raised to 1 by 2 means s raised to, you will get 2 plus 1 by 2, which will become s raised to 5 by 2. Okay, minus plus into minus are taken as it is. Then 8 you take outside. L inverse of 1 divided by underscore root s means s raised to 1 by 2. Okay, now don't worry about anything here. Now you observe these powers of SCA. Means first you have to decide which result is applicable. Okay, which standard form is in, it is in which standard form. Okay, next, therefore it is of the form again 1 L inverse of 1 divided by, sorry, this is s raised to n plus 1. But here your n is what? Your n is, in all the cases, it is a rational number. See, there is no change in the denominator. Anyway, you are going to take t raised to n only. But in the denominator, since your n is a rational number, you are going to use gamma function result here. Gamma n plus 1. So we are written it. First case. T raised to, see, this n is equal to what in the first case? First case I'll take here. I'll grab this. Okay. First case I'll take one by one. We'll take, then we'll decide. Okay. N plus 1 is equal to, you will get in the first case n plus 1 is equal to, you'll be having 3 by 2. So to get the value of n, because we want n value, this becomes 3 by 2 minus 1, which will give you 1 by 2. So what is that? T raised to, you will get 1 by 2 gamma, it is 3 by 2 only, because n plus 1 is 3 by 2. Or else you can write it as a 1 by 2 plus 1, no issues. When we do the simplification, we will do right then. Okay, then this plus 3 as it is. Now coming to this part. Okay, here in the second case, n plus 1 is equal to 5 by 2 is the n plus okay, 1 minute. In the second case, you are having n plus 1 is equal to here. Okay. N plus 1 is equal to, you are having n plus 1 is equal to, okay, n plus 1 is equal to, you are having 5 by 2. If it is n plus 1 is 5 by 2 means we want n value there. N value becomes 5 by 2. Yes, taking this to this side, it becomes a minus 1. So if you simplify, you will get n value as 3 by 2. So you can write t raised to 3 by 2 divided by gamma 5 by 2, or 3 by 2 plus 1, that minus 8, minus 8 as it is. Now this is a, yes, n is equal to, you are having in this case, I will take this particular case here. N is equal to, you are having in this case, n is equal to, you are having, sorry, n plus 1 is equal to, you are having, what you are having, 1 by 2. So what you will get there? Therefore n is equal to 1 by 2 minus 1 you will get. So that gives you, n is equal to minus 1 by 2, whatever it may be, we will write there. So it becomes our t raised to minus 1 by 2 divided by gamma n plus 1 is 1 by 2. Okay, next, now what we have to do, nothing to worry about the numerator part. We need to calculate the value of this, we need to calculate the value of this, we need to calculate the value of this. Okay, now how you are going to calculate those values here? Very simple. Already you know one of the result, with respect to gamma function. Which is that result? What is that? Can anybody remind me?
Gamma of n plus 1 is equal to.
Yes, right. Gamma n plus 1 is equal to, this is n
N gamma
n. Okay, now this gamma 3 by 2, say I'll write here gamma 3 by 2, this can be written as, already you know, this can be written as yes, 1 by 2 plus 1, because your n is 1 by 2 here. So you can write directly this one as 1 by 2 gamma 1 by 2. Am I right? So this becomes what? 1 by 2 to root pi. Okay, all of you agree? Now coming to this gamma 5 by 2. Please, if you do not understand, please tell me. Gamma 5 by 2, I will write this one as first. Gamma, what is your n in this case? 3 by 2, so it can be written as this is n plus 1, okay? 3 by 2 plus 1. Using n gamma n result, you can write this one as 3 by 2, that is gamma 3 by 2 into gamma 3 by 2. But already we are having a gamma 3 by 2 value here. So you can write directly this one, this value as 3 by 2 into, I'm sorry, 3 by 2 into 1 by 2 into root 5. So you got gamma 5 by 2 value is 3 by 4 into root pi. Then gamma 3 by 2 value is 1 by 2 into root pi. And gamma 1 by 2 value already you are familiar with that. That is a standard value. What is gamma 1 by 2 value? Yes, gamma 1 by 2 value is already you know that is a root pi. Now
Five.
you got, okay, you got this value, you got this value. Substituting all this in the denominator here. What happens? It becomes, you can write this one as here. I'll tell one more step extra here. So this value is 1 by 2 to root pi. So in the denominator, if you write 1 by 2 into root pi, so that becomes t raised to half, that is root t. T raised to half is root t divided by actually you will get this one as s root pi divided by 2 you will get if you multiply actually, okay. So if you take it to the numerator, that becomes yes 2 divided by root pi. So first term you will get after simplification 2 into root t divided by root pi, or else in some books directly they will write 2 into root pi, sorry, I'm sorry, 2 into uh, root of t divided by 5. This is also valid answer. Is that clear? The next, substitute this value here. What is that? Gamma 5 by 2 is t raised to 3 by 2 fixed as it is. This 3 raised to 2 by 2 can be written as t root t, or you can keep that as t raised to 3 by 2 only, no issues. Then this is 3 by 4, you can write this one as 3 by 4 into root pi. 3 by 4 into root pi. When you take it to the numerator, this 3 get cancels. You will get 4 times t root t whole divided by, that is divided by root pi. Then minus 8 as it is. 8 as it is, t raised to 1 by 2, first we keep as it is, its value is root pi. So t raised to 1 by 2 means you can take it to the denominator and you can write this one as 1 divided by root t. So you can write this answer as 8 divided by root pi into root t, or root underscore root pi into t. Okay, this gives you the final solution. Is there any issues or any uh, queries in this example?
No, sir.
Yes. Is that clear? All of you clear, no? Clear, or you have any difficulty or any doubts? With this one, that is examples on the basic form is completed now. Now, inverse, so these are the very simplest examples. Inverse Laplace transforms, when you do, they will be given in a different form. One by one, we will take, because we have learnt many properties, there isn't it? We have learnt many properties. Now, depending on the properties of the Laplace transform, how to find the, if they are given, using the properties when they are given, how to solve, how to find the inverse of those, we'll check now. First, we will consider computation of, that is the calculation of inverse Laplace transform of the form e raised to as into f bar s. E raised to as into f bar s, when you are going to get that, see, this e raised to as you will get whenever your function is in the form unit step function u of t minus a. Okay, 2 days back only we learned this, isn't it? So we already know that Laplace transform of f of t minus a, this is Laplace transform, not inverse, okay, into u of t minus a, it is given as e to the power minus as into f bar s. What is this f bar s? Yes, that is we are going to convert this f of t minus, this will be in the form f of t minus a, you need to convert that in terms of you need to convert that in terms of t by changing t to t plus a, and then you will get f of t. Then after that, apply Laplace to that, you will get a f bar s. You know how to calculate this. Okay. Now we are not required to find this. We know how to find that. But what happens now? Suppose if your function is given in terms of s in this manner, then how to find? We have to obtain this. We have to express that in terms of a time function, unit step function. Okay. Now what happens? Just symbolically, you are going to write it as a L inverse of e to the power minus as into f bar s is equal to f of t minus a into u of t minus a. Now the question is, symbolically we have written this using that result symbolically here. Now the question is how to obtain this result. That is very very important given this. So what are the things you need to take care here when you are going to express a given function in terms of unit step function, given inverse function in terms of unit step function. Suppose if you are see if this e to the power as if it is not present directly, you can reduce this f bar as to the standard forms, any one of the 9 forms, then you can find the inverse transform. But suppose if it is multiplied by e to the power minus as, so it's not possible to write directly inverse transform. So it should be in terms of unit step function. How to do that? will I will give some 2 or 3 steps here, methods. If you remember that, remaining thing becomes very very easy. Is that clear? Is that clear?
Yes,
Stop.
sir.
Okay. Whenever they are asked you to find a inverse of some function, inverse Laplace transform of some given function. Now we should observe whether e to the power minus as type exponential type function is present there or not. Present there or not. If it is present, find out that if it is present. Next, what you have to do? Remaining term except e to the power minus as term, remaining part is treated as a f bar s. Remaining part should be treated as a f bar s. Now once you find out what is e to the power, what is that, you take that outside, remaining part is treated as a f bar s. Now f bar s will be in the standard form, or we have to reduce that in the standard form. Standard form is inverse standard form. Then applying inverse to that f bar s, find out f of t. This is the second stage. Nothing to worry. Find out f of t. After finding f of t, in f of t, because of presence of this e to the power minus as, wherever f of t is there, sorry, after finding f of t, wherever t is there, replace that t by t minus a. Replace that t by t minus a. Is that clear? After replacing t by t minus a, then whatever the answer f of t will get there, then that should be multiplied by u of t minus a, or h of t minus a. That gives you the final answer. Is that clear? Is that clear?
Yes, sir.
Okay. So moral of the story is, what you have to do, if they ask you to find inverse of some function given, first you have to find whether e to the power as is present or not. If e to the power minus as or plus a, if it is not present, exponential term is not present, directly it will be in the any one of the standard form. So you can use those standard forms, then you can write inverse directly. If this is present, then remain except this term, remaining term should be treated as a f bar s. Then find inverse of that. After finding inverse of that, wherever t you will get in the f of t, replace that t by t minus a. Where from where you are going to take this a, from where you are going to take a value, it is the coefficient of s in the exponential's power. Is that clear? So immediately after that, once you replace t by t minus a, if it is plus a, you have to replace it by plus a. If it is minus a, you have to replace it by minus t plus a. Okay. If it is minus a, t minus a. If it is plus a, t plus a. Then after that, you have to multiply it by whatever the answer is there. You have to multiply that by f of t by u of
t minus a if it is minus here, t plus a if it is plus here. Is that clear? Is that clear?
Yes, sir.
Okay. Now, to understand this, we will take some examples which are very, very easy. See here. Find example number one. Find inverse Laplace transform of inverse Laplace transform of 1 plus e to the power minus 3s divided by s square. Okay, whatever it may be. This is your f bar s now completely. Now, what we will do, we'll solve this. That is solution. L inverse of 1 plus e to the power minus 3s divided by s square. We will write that. Now, you observe in the denominator you are having a sum of two terms. In the denominator you are having only one term. So, what we will do here? We will take a we will take a denominator separately to this s and to this e to the power minus 3s. So we can write this one as a term by term operating this inverse operator. We can write this one as L inverse of 1 divided by s square plus L inverse of e to the power minus 3s divided by s square. Okay. Now, don't worry about this now. We'll think of this later. Now, concentrate on this. This is in the standard form or not? No e to the power s term is present here, isn't it? So, it is of the form 1 divided by s raised to n plus 1. N plus 1 is equal to 2 you are having here. So, n plus 1 is equal to 2 means you will get n is equal to 1. So, using this formula, L inverse of 1 divided by s raised to n plus 1, n plus 1 is equal to t raised to n. This is common in both, okay, whether a rational number or a whole number. So, that is because this becomes a n factorial. Since n is a integer, you can use this result. You can write this one as t raised to 1 because n is equal divided by 1 factorial. This, no issues with this. Now, please concentrate on this term here. You are having a e to the power minus 3s in the numerator, and in the denominator you are having s square. So what you should do here is e to the power minus 3s. You don't worry about this. First, treat take L inverse of f bar. That is, you take only L inverse of this. Don't worry about this. Don't write even this. Okay. Take L inverse of 1 divided by s square. What is L inverse of 1 divided by s square? Say I written here. I written here. L inverse of 1 divided by s square, changing t to t minus 3, because we have to replace t by t minus a. Here a is equal to minus 3 is there. Therefore, using that step, you can write changing t to t minus 3. Now, this term t divided by 1 factorial, it becomes t, that is as it is. Now, L inverse of 1 divided by t square. What is that? 1 divided by s square. What is that? Again, using this formula, you can write as t, but because of presence of this e to the power minus 3s exponential term, you have to write t changing to t minus 3. Next, what you have to do? Wherever t is there, this term as it is. No substitution in this, only in this term. Wherever t is there, replace that t by t minus 3. You have replaced it here. Then multiply it by the final step. This multiply it by u of t minus 3. That gives you the inverse Laplace transform of this given example. Okay, is that clear? Is that clear?
Yes, sir.
All of you, is that clear, or you have any difficulty? Because one such example comes in your examination, definitely 101%. Shall we take another example now? Shall we take another example? See, find inverse Laplace transform of 3 divided by s square plus 2 into e to the power minus s divided by s cube minus 3 into e to the power minus 2s divided by s. Okay, this is the completely, this is your f of s. Now we will apply inverse Laplace operator to this. That is, L inverse of 3 divided by s square plus 2 into e to e raised to minus s divided by s cube minus 3 into e to the power minus 2s divided by s. Now, operating this inverse operator to this term by term. Okay, you can write this. Actually, I have written this 3 here. If you want, you can write this 3 outside here, no issues. Okay, So operating the term by term, what you will get? L inverse of 3 divided by s square. 2 you take outside, then this becomes L inverse of e to the power s divided by s cube minus 3 as it is. L inverse of this becomes e to the power minus 2s divided by s. Okay. Now you have operated this separately. Now see here, this is, if you take this 3 outside here, this is of the form 1 by s square. If you this term contains e to the power minus something here, this term contains e to the power minus something. See, if these two are one and the same, you can take this as a one term only. But this e to the power a value here, you are having different here. Here you are having different. So those two should be considered separately. So now first what I will write, for our convenience, using the standard result. First I will consider L inverse of 1 divided by s square. What it becomes? L inverse of 1 divided by s square. Using the standard result, it becomes t divided by 1 factorial. So it becomes t only. Next, L inverse of here s cube is there. If you take 1 divided by s cube, forget about this e to the power. We'll think of that later. It becomes 1 divided by s cube. Using, since this is a, I'm sorry, since this is a positive integer, it becomes you can use the result there, t raised to n divided by n factorial. This is n plus 1 value is 3, means n value becomes 2. So it becomes L inverse of 1 divided by s cube. This is equal to, you can write t square divided by 2 factorial. 2 factorial value is also 2. So you written it directly. And you already know, forget about this, you already know L inverse of 1 divided by s. If you consider what is L inverse of 1 divided by s, what is L inverse of 1 divided by s? Yes,
1.
1. It is already there. Okay. Then, therefore, what happens? Therefore, L inverse of 3 divided by s square plus 2 into e to the power minus s divided by s cube minus 3 into e to the power minus 2s divided by s. This can be written as, see, this 3 will take outside. L inverse of 1 divided by s square, that already we are having, you can write it as a t. And see here, 2 as it is. 2 as it is. Here in this case, you need to calculate. Forget about e to the power whatever is present there. We'll think of that later. It is L inverse of 1 divided by s cube is there. So if you find this, that becomes t square divided by 2, where t changing to, now you have to concentrate on this a value. What is this a value here? Minus 1. So you are written t changing to t minus 1 here in this case. Now minus 3 as it is. Now here forget about this e to the power minus 2s. We'll think of that later. Then first what you have to do, L inverse of, you need to calculate here 1 by, yes, that is, what is L inverse of 1 by s? Already you have done, that is 1. So L3 into L inverse of 1 by s is 1. Then t changing to t minus 2, because here a is equal to minus 2 is there, isn't it? So now this 3t, this is no s term is there, so we'll keep that as it is. Now here, this two will cancel. According to the rules, what we have to do, if it is multiplied by e to the power minus as or minus something, e to the power minus something into s, so here it is multiplied by minus s, so a is equal to 1. So wherever t is there, you have to replace it by t minus 1. So this becomes t minus f, your f of t is t square. Here wherever t is there, replace that by t minus 1. So that becomes t minus 1 whole square into, you have to multiply that by u of t minus 1 or h of t minus 1. Okay, then minus 3 as it is. No t term is present here. No t term is present means no need to replace t by t minus 2. But what you have to do, you have to yes, right, u of multiplied by u of t minus 2, because of presence of this. See, you may ask, sir, how you are written this? Just observe. Remember, Laplace transform of, what is the Laplace transform of u of t minus a unit step function? What is this? Yes, can anybody tell me? It is e to the power minus as divided by s, isn't it? Agree? Agree or not? Agree?
Yes, sir.
Now apply Laplace transform to this. Wherever u is a is there, put t is equal to, sorry, a is equal to 2. What happens? You will get original thing as it is here. Laplace transform of u of t minus 2, if it is there, it becomes e to the power minus 2s divided by 2. So you have to write like this. Is that clear? This example is clear?
Yes, sir.
Sagar Umrani, Guru Prasad Patil, is it clear? Abdul Gafar, is it clear?
Yes, sir.
Nobody? Okay. Now, see here. Now we'll take one more example. One more example. Okay. That is, find the inverse Laplace transform. See, whenever e to the power as term is present, then exponential term is present. When you are finding Laplace inverse, then you need to be little bit careful and keep in mind, under that condition, if e to the power something is present, means definitely you are going to get answer in terms of unit step function. Is that clear? Clear? Okay. Now find the inverse Laplace transform of e to the power minus pi s divided by s square plus 1 plus e to the power minus 2 e to the power minus 2 pi s into s divided by s square plus 4. First, they are asking you to find inverse transform of this. Okay. Now, plus term is there. We'll think of this later. First, operating a Laplace inverse to this first. That is e to the power L inverse of e to the power minus pi s divided by s square plus 1 plus e to the power minus 2 times pi s 2 times pi s into s divided by s square plus 4. So this is one term, this is one term. We will operate this inverse operator to this term by term. That is L inverse of e to the power minus pi s divided by s square plus 1 plus L inverse, because this is plus here, L inverse of e to the power minus pi s divided by so minus pi minus 2 pi s into s divided by s square plus 4 is there. Now I'll pause a little bit here. Then let me tell you one hint here. So now you observe here. Here, what we told, e to the power, you have to find out first e to the power what is present. Here e to the power minus pi s is present. Here e to the power minus 2 pi s is present. Now I will concentrate on this term first. Except e to the power minus pi s term. What is remaining here? What is remaining? If you take this outside, what is remaining means, if you think that it is not present here, what we will have to the 1 divided by s square plus 1. So that becomes your f bar s. So you have to find inverse of that, that is L inverse of 1 divided by s square plus 1. L inverse of 1 divided by s square plus 1 means what? That becomes a yes, a is 1 here. It is of the form a divided by s square plus a square. In the numerator you are having a, means definitely that you will get in terms of sine. So it becomes sine, a value is 1, so it becomes sine t. Okay, with respect to this. Is that clear? Now here e to the power minus 2 pi s into s divided by s square plus 4 is there. Now forget about this or remove this, then consider only this part, only this part as your f bar s. So find inverse of that. If you find inverse of that, what happens? L inverse of it becomes s divided by s square plus 4. In the numerator you are having s, means either it is a cos hyperbolic or it is a cos. If it is plus, definitely it is a cos function. So what happens there? It is of the form s divided by s square plus a square. So this is 4 is present, means 4 can be written as a 2 square. So you can write this one as L inverse of s square, s divided by s square plus 2 square. So L inverse of this is, it becomes a cos 2t, because a is 2 here. Okay. Now we'll come to the point. Therefore, Laplace inverse transform of this quantity you have written as Laplace inverse transform e to the power minus pi s divided by s square plus 1 plus e to the power minus 2 pi s into s divided by s square plus 4 is equal to first term. So Laplace inverse transform of this just only. Therefore, Laplace inverse transform of Laplace inverse transform of this. I will write that one as s sin t. Wherever t is there, t changing to t minus pi, because e raised to you are having here minus pi s coefficient is, that is a value becomes pi. Okay. The next. Okay. Now this already you know. This is, I will write this one as L inverse of this one is cos 2t. Wherever t is there, we have to replace the t by t minus 2 pi, because here s coefficient is 2 pi. Okay. Now immediately after that, wherever t is there, replace that t by t plus pi. Once you replace the t by t plus pi, in the same step, what you have to do? You have to multiply it by u of t minus a, u of t minus a. In this case a is pi, in this case a is 2 pi. We have to use that. Okay, so we'll do that here. That is sine t plus, sorry, t minus pi, sine t minus pi into u of t minus pi. Then this cos 2, wherever t is there, you have to replace it by t minus 2. Cos 2 into, cos 2 into, yes, cos 2 into t minus 2 pi into u of t minus a. A is 2 pi here, so it becomes u of t minus 2 pi. Okay, therefore sine t minus pi, sine t plus pi or sine t minus pi, it becomes minus sine t minus sine t, that is sine theta plus or minus pi is, or sine pi plus or minus theta is minus sine theta. So you can write this one as a minus sine t. This value becomes minus sine t. This value becomes minus sine t. 1 minute. This value becomes, this value becomes minus sine t, u of t minus pi as it is. Then this, take this 2 inside, you will get cos 2t minus 4 pi, cos 2n pi plus or minus theta is cos theta only. So this becomes cos 2t after simplification plus cos 2t into u of t minus pi as it is. Therefore Laplace inverse transform of this is sin t minus sin t into u of t minus pi plus cos 2t into u of t minus 2 pi. Is that clear? This example is clear?
Yes, sir.
All of you are sure? Clear now? Yes? Okay. Now we'll check one more example. We'll take quickly one more example, then we'll stop there. Okay. Next. Okay. Find inverse Laplace transform of e to the power minus s by 2 into s divided by s square plus pi square plus e to the power minus s into pi divided by s square plus pi square. Nothing to worry. So this is your, originally this is your f bar s. So you have to find inverse of this. So L inverse of e to the power minus s by 2. Minus s by 2 means it is of the form, see, please concentrate it, 1 by 2 into s iddam. It is 1 by 2 into s. So then this is e to the power minus, sorry, minus s by 2 s into s divided by s square plus pi square plus e to the power minus s into pi divided by s square plus pi square. So two terms are there. Operating this L inverse separately to these two terms, what happens? L inverse of e to the power minus s by 2 into s divided by s square plus pi square plus L inverse of e to the power minus s pi divided by s square plus pi square. Okay. Now we'll go a little bit slow now. Now here also e to the power something is present, exponential term is present. Here also exponential term is present. Now what we should do? We'll go step by step. Don't worry about this step, except that, I will show you, except that this term this term should be treated as f bar s here, and this term should be treated as a f bar s here. Now take this L inverse of this f bar s, L inverse of s divided by s square plus pi square. Say it is of the form s divided by s square plus a square. So a is equal to, you are having here pi, a is equal to, you are having a pi. Okay, so what happens? So if it is a, you would have written this one as cos 80, but in place of a you are having a pi there, so you can write this one as a cos pi t. L inverse of s divided by s square plus pi square is cos pi t. Now this one here, L inverse of this is this pi divided by s square plus pi square is there. You can write directly this one as a sine pi t using the standard. Actually, you can take this pi common, then you can write this one according to standard result. You can write L inverse of 1 divided by this is s square plus pi square s square plus pi square. So what happens? This pi as it is, this can be written as 1 divided by, I'll write quickly, 1 divided by psi into, sorry, 1 divided by pi into sine pi t. So this get cancels. So instead of that, I have written it directly. Okay. So this is sine pi t. Okay. Next, what you have to do? You got in both the cases e to the power something is present exponential term. In both the cases, you got a, yes, in both the cases you got a f bar s values. So what you have to do? Consider that is therefore L inverse of e to the power minus s by 2 into s divided by s square plus pi square plus e to the power minus s into pi divided by s square plus pi square. So operating separately, this becomes cos pi t. But e to the power you are having here e to the power minus s by 2. So t changing to t minus 1 by 2. But in this case it becomes sin pi t. But here it is multiplied by e to the power minus s. So it becomes t changing to t minus 1. So replace whatever it is there. Therefore, cos t is there. You have to replace the t by t minus 1 by 2. In this case, t by t minus 1. So it becomes a cos pi into t minus 1 by 2. Whenever you replace this, what you have to do? You have to multiply it by unit step function u of t minus a. Here a is 1 by 2. So it becomes a u of t minus 1 by 2 plus sine pi into t minus 1. Wherever t is there, you have to replace it by t minus 1 into you have to multiply it by u of t minus 1. Further simplification, taking this pi inside the bracket. So it becomes what? Cos pi t minus cos pi t minus pi by 2. So you can write this one as a cos pi t to u of this function as it is. Then if you take this pi inside, that becomes sin pi t minus pi. So that becomes minus sin pi t into u of t minus 1 as it is. So this is how we got the inverse Laplace transform of this. Whenever exponential term is present, when we find the inverse Laplace transform, we need to be little bit very very, not little bit, very very careful. Hope today's examples all of you are perfect. Understood?
Yes, sir.
Pakka?
Yes, sir.
Okay, just 1 minute. All of you understood this? All you understood? Sure? Hope all